Okay, Assalamualaikum and good day. So today we are going to continue with the last lecture for chapter 4, topic 4, which is topic linear programming. And then we are going to solve on the subtopic 4.2, which is problem interpretation, formulation, and solving. So for this part, we need to interpret the problems given. Usually it's a real life situation. And then formulate all the related problems and solve the system of linear inequality lah. Okay, so the learning outcome at the end of the lesson, students should be able to identify the variable from the problem statement. Okay, so you need to know what are the variables that we will going to use in the problem. And then determine the objective function of the problem. So this is a new thing for you guys. You need to know what is the objective function. And then formulate the system linear of inequality. So you need to formulate what are the system of linear inequalities from the problems. Lastly, compute the optimal value of an objective function using the vertices of feasible region. So sekarang ni kita nak kena tahu daripada problem tersebut what are the variable that we are going to use, and then what are the objective of the problem itself, and then formulate the linear inequalities, the system, and then find the optimal value of the objective function. Okay, now we suppose that one city has RM 450 ringgit to buy reference books for her school's library. Okay, now she have a total of 450. On the average, a mathematics book costs RM 15, while a general science book costs RM 10 ringgit. The school library needs at least 5 general science books. Furthermore, the number of mathematics books to be bought at least 10 or more than the number of general. How will Puan Siti use the money to buy as many books as possible? Okay, now, first thing we need to know is what are the representation in mathematics. Okay, so we have a fund to buy mathematics and general science books that we know. And then the price for mathematics is 15, average, on the average, while general science book is 10. Okay, at least 5 general science book, and then mathematics must be at least 10 more than number of general science book. Okay, so how to solve this problem? Okay, so problem interpretation is a process of converting daily problem into a form that can be solved using mathematical approach method. So we have the real life situation. Now we want to convert in mathematical method so that we can solve it using the mathematical approach. So certain decision needs to be made. Decisions are represented by decision variables. Okay, the basic structure is either to maximize or minimize an objective function. So this is our target lah. Maybe for maximizing a profit or minimizing the cost or the spend, okay, while satisfying set of constraining condition or constraint. Okay, so we have this objective function, but we have to satisfy all the conditions. So that's why we use this linear programming. Okay, the first step in problem interpretation is interpret the problem by determining the variables. So the variables are non-negative. So these x and y can be the variables. So for linear, we only have 2 variables, right? So we either have x or y. Now to determine what is the x, what is the y. And then this variable must not be a negative number. So it always positive lah, or 0 can be. So forming related inequalities. Okay, now the second step is inequalities or equation for mathematical model. Okay, so we want to form, after we have the variable, we have to form the inequalities lah. The third one is determine the objective function of the problem. So what are our objective from the questions, from the problem? Now, model formulation is a process of translating information into equation or inequalities using mathematical approach. So what we are doing in translating the problems into mathematical form is a model formulation. Okay? Note that certain keywords can be interpreted in the form of inequalities such that, so these are several words that may be used in representing these inequalities lah. So for example, for less than is less than lah, and then less than equal, it can be maximum, it can be available, up to, does not exceed, at most, not more than. So you have to make sure that you use the you interpret the correct word. Okay, so available, it can be we use everything, or we might skip some of it. So that's why it will be less than or equal to. Okay, and then the next one is more than or exceed. Okay, this symbol is more than or exceed. And then the next one is more than equal. We can also use minimum or at least, not less than. More than equal pun boleh. Okay, so please take note all of these keywords. Problem solving using corner points, vertex method. So we only learn how to find how to solve the problem by using this method lah. We only learn this part. Okay, a corner of a feasible region is a point in the feasible region that is the intersection of two boundary lines. Therefore, the corner points method for solving linear programming problems is as follows. So step 1, graphically identify the feasible region. So we learned this in the first and second lecture. Okay, we can sketch the graph and identify the feasible region of the system of linear inequalities, and then determine the coordinate of each corner point in the feasible region. So after we find out the feasible region, we find out the coordinate of each corner point. Coordinate of each corner point in the feasible region, and then substitute the coordinate of the corner points into the objective function to determine the corresponding value. So we substitute into objective function, and then look at the objective function whether we want to maximize or minimize. So an optimal solution occurs in a maximization problem at the corner point, yielding the highest value of the objective function, and in a minimization problem at the corner point, yielding the lowest value of the objective function. So we either want to look at the maximum or the minimum. So depends on the question itself. Okay? Okay, now we have the problem. We want to interpret this problem. First of all, what we need to do is to determine the variables, right? So a factory produced two types of radio, hi-fi and mini, using machine P and Q. Okay, then we have machine P and machine Q. In a month, the factory produced X unit of hi-fi model. So the quantity X of hi-fi, so X is representing the quantity for hi-fi model, and Y unit of mini model. So it's actually representing X is a quantity of hi-fi and Y quantity of mini. Machine P needs 40 minutes and 30 minutes to produce each of hi-fi model and mini model respectively. Okay, so P for hi-fi needs 40 minutes, but for mini, it needs 30 minutes to produce. Machine Q needs 20 minutes for hi-fi and 35 minutes respectively for the mini model. production in the months of the company is limited by the following conditions. So they give you the condition again. Now, the amount of time used by mission P does not exceed 4,500 minutes. So mission P must not exceed, the amount time used by mission Q does not exceed 2,800 minutes. The number of hi-fi model produced must be exceed 3/2 times of mini. Wow. So how many conditions we have here? Okay. So now we know that X is the quantity of hi-fi and Y is quantity of mini. So now write down the system of inequalities of the problem. So we want to find what are the system of inequalities. So what we can relate with all this problem. State clearly the constraint and the objective function pi for the profit that can be achieved if the profit of each unit of the modern hi-fi and mini is 80 and 40 ringgit respectively. Okay, so we have given the objective function, which is the profit. So the objective function we get. Now state clearly the constraint. Okay. Now let's see what are the system of linear equations, system of inequalities. First of all, the above information is summarized in the following table. So for hi-fi and mini, they said that the P machine can produce hi-fi in 40 minutes and then for mini is 30 minutes. But for Q, hi-fi can be produced in 20 minutes and mini can be produced in 35 minutes. Okay. And then what are the constraints? The constraint depends on the machine itself. So what are the constraints of the machine? So mission P has a constraint. Why? Because they can be used for 4,800 minutes only for a week. So this is the constraint. So maximum 4,800 minutes. And then for Q also, there has a constraint which is 2,800. Okay? And then we have a profit for each of hi-fi and mini. For hi-fi it's 40 ringgit, 80 ringgit. For mini it's 40 ringgit. Okay? For profit we don't have constraint. We don't limit the profit. So we don't have constraint. So this is the objective function. So the constraint, if we list out, it's a 40x plus 30y. So 40 minutes for each of the hi-fi plus with 30 minutes for each of the mini for mission P. So it must not exceed 4,800 minutes. Okay. So because for hi-fi, untuk hi-fi dia perlukan 40 minit. Untuk mini dia perlukan 30 minit. Okay, so how many quantity? Kita darabkanlah 40 darab berapa banyak hi-fi, 30 darab berapa banyak mini, and then semua tu mesti total kurang ataupun sama dengan 4,800. Okay, and then for mission Q, for hi-fi we need to use 20 minutes kan. So multiply with quantity or hi-fi which is X plus with 35 minutes needed for mini which is multiplied by Y. And then the constraint also cannot exceed 2,800 minutes. Okay, so it less than or equal to 2,800 minutes. Okay, so everything in minutes. Here in minutes, on the right side also the same unit lah. This is minute, this one also minute. Okay, make sure you use the same. And sini minit, sini belah kanan pun minit. Kalau dia bagi dalam seminggu kena guna dalam 4 jam, so you kena convert to minutes lah. So 4 multiplied by 60. Macam tu lah. Tapi sekarang semua dalam unit yang sama, tak ada masalah. Okay. Lepas tu dia ada bagi juga profit dia. Oh sorry. The third constraint kat sini dia kata penghasilan hi-fi must be 3/2 times more than Y. More than mini. So hi-fi kena lebih banyak daripada mini sebanyak 3/2 kali ganda. So quantity kita boleh represent dia dalam bentuk X and Y lah, variable dia. So the third constraint is X is more than 3/2 Y. Okay. Lagi apa lagi constraint kita ada? Kuantiti mestilah lebih daripada sama dengan kosong. Dia tak boleh negatif. Ini kita masukkan jugalah. Dia wajib lah untuk problem solving ni. And then kita ada objective function pi for the profit of the factory in a month, which is darabkan dengan setiap kuantiti bagi dia punya profit. So kalau hi-fi profit dia 80, so 80 darab X. Kalau mini profit dia 40, which is darab dengan Y lah, quantity of mini. Okay, so kita dah ada constraint, kita dah ada objective dah. Okay ke? Okay, so tadi kita buat example 1, kita tahu nak keluarkan kita punya constraint, kita punya objective function. Tapi objective function tu untuk apa? Macam mana nak selesaikan dia? Dah ada constraint, dah ada objective function. So constraint tu you boleh lukis atau linear atau graph kan? Dapat dah feasible region. Tapi apa gunanya objective function tu? So kita belajar sekarang macam mana nak selesaikan objective function tu dengan constraint yang ada. Okay, so biasanya soalan dia kalau yang problem solving dia tak bagi direct macam ni lah. Dia akan bagi situation and then dia kata solve. Macam tu je lah. So tapi apa yang kita kena buat, what we have to do is to maximize. Contohnya kalau soalan tu maximize ataupun find the highest profit lah kan. So kita assume dia adalah maximizing the objective function. Okay, kalau example 1 tadi kita nak cari highest profit. Okay, so the highest profit by applying the constraint juga. Kena ikut syarat-syarat tu, betul tak? So syarat-syarat tu lah yang kita kena lukiskan dalam graph. Okay, so maximize the objective function. So objective function ni kita sentuh lepas settle kita punya feasible region. Okay, sekarang ni apa you buat? The constraint semua ni you kena lukiskan. You have to draw it on your graph paper. Kenapa? Because the point kita boleh directly ambil daripada graph paper. Okay, tapi kemungkinan juga kita punya graph paper tu tak betul, kita punya lukisan tak betul, nak selamat kita kena gunakan simultaneous equation. Okay, tak apa. Apa pun kita tengok ah. So, first step kita draw the equations lah. Kita ada berapa equation kat sini? 1, 2, 3, 4. Okay, equation 1 dengan 2 ni simple. Y and X exist. And then, untuk yang equation ketiga, 2X tambah Y less than equal to 8, dia adalah sama dengan apa? Equation yang ketiga, 4 pun sama. You kena lukiskan equation ni. So, biasanya macam tadi kawan awak kata, dia suka letak jadikan Y perkara rumus, tak ada masalah. Tapi kalau saya terus je 2X tambah Y sama dengan 8, cari saja bila X sama dengan kosong, Y sama dengan apa. Macam kita buat dekat soalan yang sebelum ni kan. So, bila X sama dengan 0, Y equal to 8. When Y equal to 0, X equal to 4. So, you ada dah point dan you boleh lukiskan graph. You dah ada intercept dia. Sama juga untuk equation yang seterusnya ni. Kita ada 2X tambah 3Y sama dengan 12. So, bila X sama dengan kosong, Y sama dengan 4. Bila Y sama dengan kosong, X sama dengan 6. So, you dah ada 2 point, you boleh connect the 2 points. So, kalau kita tengok lepas tu, identify the feasible region. Macam biasalah yang kita buat sebelum ni. Kita dah lukiskan graph. So, ini graph kita lah. Yang pertama 2X tambah Y. Ini kita kira tadi. And then kita dapat 2 point. Kita connect dia. And then dia ada equal sign. So kita guna solid line. And then equation yang kedua. Kita ada 2X tambah 3Y sama dengan 12. Ada 2 point juga. 0, 4, 6, 0. So connect the 2 points. So sekarang satu lagi point dia. Kita nak cari feasible region. X more than or equal to 0. Y more than or equal to 0. So cari dia punya feasible region. Okay. So, ini adalah feasible region. Kenapa? Untuk 2X plus Y equal to 8, dia punya inequalities adalah less than or equal to. So, it's going the lower half plane. Sama juga untuk 2X plus 3Y is less than or equal to 12. So, it's lower plane juga. Tapi, untuk X, it should be more than equal to 0. Untuk Y, it's more than or equal to 0. So, kawasan yang ada keempat-empat tanda ni adalah kawasan ini. So, this is the feasible region. Okay. Now, in this feasible region, kita ada corner points. Okay. You tengok dekat vertex ni, bucu-bucu semua tu. Okay, bucu-bucu ni lah yang kita akan gunakan untuk cari objective function. Nak solve the objective function. Okay. kita ada point 4. Sebab 4 side sepatutnya akan ada 4 vertex lah, 4 bucu. 4 vertices. So, point A, point B kita labelkan dia sebab senang nak tengok point apa. Okay, untuk point A, directly it's an origin. So, point 0, 0. Untuk point B, dia adalah intercept kat sini. X-intercept which is 4, 0. Untuk D pun intercept which is 0, 4. Tapi untuk C, kita tak tahu. That's why kalau kita lukis graf, sketch secara betul tepat atas kertas graf, kita boleh nampak directly point tu. Tapi kalau dia berada di antara, dalam skala tu di antara 4 dengan 3, di antara 2 dengan 3, so you kena cari titik C ni. So determine the corner points. The coordinate A, B and D are obvious on inspection. To find the coordinate C, solve the equation simultaneously. Sebab dia adalah intersection point between the lines lah. So kita solve dia simultaneously equation 1 and equation 2. Kita from equation 1 and 2 kita boleh buat apa? Tolakkan dia. Kat sini dia buat equation 1. Dia jadi 2x equal to 8 minus y. Yang tu satu lagi. And 2x equal to 12 minus 3y. So dia compare the right sides ni. 8 minus y equal to 12 minus 3y. Ataupun you boleh buat je equation 1 minus equation 2 kan. 2x minus 2x 0. Y minus 3y is negative 2y. 8 minus 12 is negative 4. So y is equal to 2. Sama jawapan dia. Y equal to 2. Selesaikan. Okay. And then dia dapat y equal to 2. X dia apa? Substitute lah dalam mana-mana equation 1 atau equation 2. So bila y sama dengan 2, x akan jadi sama dengan 2x plus 2 equal to 8. So 2x equal to 6. So x equal to 3. So kita ada keempat-empat point, corner points kita, which is the vertex lah. So sekarang apa gunanya points ni? Point-point inilah yang digunakan untuk tengok, check sama ada kita dapat maximize tak objektif tu. Apa kita perlu buat? Kita substitute the corner points into the objective function and choose the optimal value. Optimal ni maksud dia apa? Tengok soalan lah sama ada you nak maximize or minimize. Yang paling terbaik. So kita ada 4 corner points. So untuk point A, 0, 0, substitute dalam objektif, kita dapat kosong. Untuk point B, 4, 0, substitute into the objective, nilai X dengan Y coordinate dia, dapat 3 darab 4, 12. And then untuk point C, which is 3, 2, yang kita cari tadi tu, substitute into the objective function, we get 3 of 3 plus 2. So 9 plus 2 is 11. And then the last one is 0, 4. Point D. So substitute you akan dapat 4. So what are the object we want to achieve? We want to maximize. Betul tak? Z is maximum. Yang mana satu paling tinggi? So antara keempat-empat nilai ni 12 yang paling tinggi. Betul tak? So kita pilih point B. Yay. So B is the best corner lah. Macam tu. So conclusion dia kat sini. Ini conclusion dia. Z, the objective function, is maximum when x equal to 4 and y equal to 0. 0.40 ni. The maximum value Z is equal to 12. Okay, contoh kalau dia profit kan. Dia akan cakap, okay, profit akan maksimum kalau kita hasilkan produce 4 hi-fi ataupun dan 0 mini. Contoh saya bagi example relate to example 1 tapi dia bukan yang tak sama. And then the maximum value and then profit yang tinggi adalah RM12. Contoh ya kat sini. Okay. Itu adalah kalau di dalam bentuk real life situation. Tapi sekarang ni just directly find the maximum point ataupun maximum value kat sini. Maximum point X dengan Y coordinate, maximum value nilai Z tu sendiri, the objective function itself. Boleh ya? Okay. Okay, now let's continue with the next example, which is example 3. To minimize the objective function z equal to 3x plus 6y with the constraint subject to 4x plus y more than or equal to 12, x plus y less than or equal to 20, x plus y is more than or equal to 10, and xy must be more than or equal to 0. So how many constraints we have? We have 1, 2, 3. This is standard in the first quadrant only. Okay, so first of all, draw the following equation. The three equation that we have here, which is for x plus y equal to 20, x plus y equal to 20, x plus y equal to 10. Okay, so we draw on the line and then identify the feasible region. So we have the graph here, x and y axis. And then for x plus y equal to 20, when we find out the intercept, when x equal to 0, y is equal to 20. When y equal to 0, x equal to 5. Okay, so we have 5 at y-intercept. So sketch using the correct scale. Okay, so this is 20 around here, and this is 5. So straight line and then equal sign. So we have a straight solid line. And then for the second one, x plus y is equal to 20. So when x equal to 0, y equal to 0. When x equal to 20, when x equal to 0, y equal to 20. When y equal to 0, x equal to 20. Okay, it's 20, 20. So connect the 2 points. We have equal sign, so solid line again. And the third one is x plus y equal to 10. Okay, so when x equal to 0, y equal to 10. When y equal to 0, x equal to 10. So we have intercept at 10, 10. So connect the 2 point, 10, 10. And then we have to make sure the area bounded by x more than or equal to 0 and y is more than or equal to 0. So the inequalities. Now, for the first one, it's more than. So more than, it should be upper half plane. And then for the second one, it's less than equal. So it's lower half plane. And the third one also upper half plane. And then it should be more than or equal to 0. Right? So the graph here should be, so we don't have to put here because everything here will be more than or equal to 0. So the feasible region is around here. Now we have the feasible region already. The third step is to find the corner point. So because we have 4 sides, 1, 2, 3, 4, even though we have 5 inequalities, so we only have 4 vertex. So the point A, B, C, D, which one you want to label A, B, C, D, that doesn't mind. Just take the vertex. So let's say this one is A, and then we have B here, C, and D. So for A, C, and D, directly we know the point, which is A is 0, 20, C is 10, 0, D is 20, 0. But for B, we need to find the intersection between the line for x plus y equal to 20 and the line x plus y equal to 10. Okay, so the coordinate B, find the intersection simultaneously. So 1 minus 2, 4x minus 1 is 3x, 3x equal to 10, so 10 over 3 lah. So x equal to 10 over 3, so y is equal to 20 over 3. So we have the point for coordinate of the coordinate for point B. So after that, we find out what is the objective, the results for the objective function. Okay, so we have 4 points here. Now substitute the corner point into objective function and choose the optimal value. So all the 4 points, A is 0, 20. Substitute into the objective, which is z equal to 3x plus 6y. So we get 120. For point B, 10 over 3, 20 over 3. Substitute value, we get 50. And then for C, 10, 0, we get 30. And then for D, we get 60. Just substitute into the objective function. So for this question, we want to minimize, right? So which one is the minimum value? Out of these three, which one is the minimum one? Of course, it's 30, right? So the point that we choose here is point C, where x equal to 10 and y equal to 0. So the minimum value of z is equal to 30. Okay, so it's depend on what we want to find. The optimal here, they ask you to find the minimum. Minimize the objective function. Okay, so this is how do we solve for the direct question. Now, to continue with the problem equation, problem statement. Okay, so let's continue with the next example. Okay, so example 4. Wow. Okay, so this is the real life situation. Let's say we have this situation. How do we solve for this couple? Okay. Okay, so now a retired couple have up to 30,000 to invest in fixed income securities. Okay, so they have this money to what we call invest, right? So of course, usually we want the highest return. Okay, we can invest many things in many things, either fund or trust or bond. It's up to that's why we have to know this type of uh, situation. Okay, their broker recommends investing in two bonds. One AAA bond yielding 8%. Okay, the other a B plus bond paying 12%. After some consideration, the couple decide to invest at most 12,000 in the B plus bond. Investment in AAA bond is recommended to be at least 6,000. The couple also want the amount invested in AAA bond to exceed or equal the amount invested in B plus bond. Okay, if X and Y represents amount invested in AAA bond and B plus bond respectively, what should the broker recommend if the couple want to maximize the return of their investment? State also the minimum and maximum return of their investment. Okay, we have 30,000 now. We need to decide how many we need to spend on AA bond and how many we need to spend on the B plus bond. Okay, so they said that couple decide to invest at most 12,000. So it should be less than or equal to 12,000 lah. So this statement at most here is important for you. Okay, this is the representation of at most can be written as less than or equal to. And then for AAA is written at least, so it should be more than or equal to. Okay, let's say X is the bond, X is represent AAA bond, the investment in AAA bond, and Y represent the amount invested in B plus bond. Okay, so what are the other statement? The couple also want the amount invested in AAA bond exceed or equal, more than or equal to B plus bond. Okay, so let's say X is amount invested in AAA bond, Y is amount invested in B plus bond, the quantity to be maximized, the couple return on investment which denoted by P. So we want to know the returns, right? The highest maximum return. So we didn't include the original investment. Just take out the objective function. Why? Because for the AAA bond, the return is 8%. So 8% of the amount is 0.08 multiply the amount. That's why 0.08 multiplied by X, which is the amount for invested in AAA bond. And then 0.12 multiplied by Y, adding up with the profit from the investment in the B plus bond, which is 0.12, 12% multiplied with the amount itself. So 0.12 multiplied by Y. So this is our objective function. Okay, because of the return itself. We want how many return. That is to maximize the return. We have to know what are the return first. Okay, so this is the objective function. The condition specified by the problem. So up to 30,000 available. So the total amount invested in both AAA and B plus bond should be less than or equal to 30,000 lah. Because that is the money available. So we cannot use more than that. But less than is okay. Okay. So this is the first constraint that we need to consider, because the total amount should be less than or equal to 30, because this is only the investment that the money we have to invest. And then invest at most 12,000 in B plus bond. So Y should be less than or equal to 12,000. And then at least 6,000 in AAA bond. So X the amount invested in AAA bond should be more than or equal to 6,000. And then the investment in AAA should be at least or must exceed or equal. So it should be more than or equal to amount in B plus bond. So X should be more than or equal to Y. Cannot be less than. Okay. So now we have these 4 constraints to consider. Okay, now how do we find the value of X and Y that satisfy all of these conditions to get the maximum profit? What we can do is to apply the linear programming, which is by sketching the graph. So, in addition, we must have the condition X should be more than 0 and Y should be more than or equal to 0 lah, because the money cannot be negative lah. Okay? Okay, so let's sketch all the constraints on the graph to see the feasible region and find the corner points. So we have the first one, we can take the first one, X more than 6,000. And then we also have Y, X equal to Y, or X less than, X more than Y. Okay, so X more than Y or Y equal to X lah. It will be Y less than or equal to X. Okay, this is when X is more than or equal to 6,000. And then the third one is X plus Y is less than or equal to 30,000. The investment, total investment less than or equal to 30,000. And the investment in bond B plus should be less than 12,000. Y less than 12,000. Okay, now we want to find the feasible region. For the first line, X is more than 6,000, so it should be to the right side. So I will put the arrow on each section. And then for this one, X is equal to Y or Y equal to X. But we have X more than or equal to Y, which is equivalent to Y less than or equal to X. So remember, Y on the left side, so we want the less, so it will be below. So it will be this part. Okay, lower half plane. And then the third one, let's say we take this one, Y should be less than 12,000, so below, it's going down again. And then for the last equation, Y, X plus Y is less than 30,000, so this line it should be lower half plane also. So we can see that for the feasible region that has all the arrows is actually this one, 1, 2, 3, 4. This one 2, this one 1, 1, this area only 2, this area only 1 arrow, this one only 1, this one only 2, this one only 1, 1. So this one has 4. So this is our feasible region. So this feasible region we has how many points? Corner points? Because we have 1, 2, 3, 4, 5 sides. So we should have 5 corner points, which is we can represent it as A here, B here, C, D, E. Okay, so for A, B, it is really obvious because it's just intercept. This is when X equal to 6,000. So 6,000, 0. And B also it's 30,000, 0. But for EDC, we need to find. CDE, we need to find by using substitution. Sorry, by using simultaneous method. Okay, so what are the points that satisfy the feasible region? So we have A, B, C, D. Directly for A, we have 6,000, 0 and B, 30,000, 0. But for C, it's an intersection between, for C, the intersection between X plus Y equal to 30,000 and Y equal to 12,000. So we get X equal to 30,000 minus 12,000, which is equal to 18,000. Okay, and then for point D, it's an intersection between Y equal to 12,000 and Y equal to X. So directly X equal to 12,000 also. So that's why the point is 12,000, 12,000. And then for E is a point, the intersection between Y equal, sorry, not Y, but X. x equal to 6,000 and line y equal to 6,000, y equal to x. Okay, so y is equal to 6,000 also. So this is the point E. Okay, so we find out the intersection between the two equation 1, 2, 1, 2. Okay, so we find out the point already lah. Okay, so after that, the corresponding return on investment of each corner point is, so we substitute all the points into the objective function. So for point A, the profit will be 0.08 multiplied by 6,000 plus 0.120. So the return is 480. For point B, B or E. Oh, so point E, they ask for, they find out for E first. 0.08 multiplied by 6,000 plus 0.12 of 6,000, we get 1200. And then for point D, we get 2400. For point C, we get 2880. And then for point B, we get 2400 also. Okay, so out of these 5 investment, which one give you the maximum return? Okay, the maximum return on investment is obtained when, yes, 2800 is the maximum return we have. When the x equal to 18,000. X is the bond, the investment spent on bond AAA. Okay, so 18,000 is invested in the AAA bond and 12,000 invested in B plus bond. So this is the maximum return. The maximum return will be the 2,880, and the minimum return, if we see here, it will be 480 ringgit. Okay, so we answer all the question asked in the problem. Okay, so that's all you need to know. But the thing is, you have to know how to interpret lah. So English, you need to be power lah. English, and then translate one by one. Make sure you understand what the question give you lah. Okay, so that's all for this lecture. Finish chapter 4. Okay, you can try to do the tutorial number 3, question number 3, 4, 5, and continue with the miscellaneous.